Okay, so here we are on 13/8. So sine is the reciprocal of cosecant, cosine is the reciprocal of secant, tangent's the reciprocal of cotangent, or these are the reciprocals of that, I should say. So here we're given cosine is 5/13, so find the secant. Well, the secant is the reciprocal, so it is just 13/5. What if I wanted to find all of them? What if I wanted to find all 6 trig functions? Could I do that? How could I do that, Psychandra? Very good. Because basically, you know 2 out of the 3 sides. Here, if I would draw 5/13, this is adjacent over hypotenuse. So this is 5 and this is 13. By the Pythagorean theorem, you could find out what y is. 5 squared plus y squared equals 13 squared. So you'd have 25 plus y squared equals 169. Y squared is 144, so y is 12. So right now I could find them all. So on this, what would be the sine of theta on here? This is theta, made up of the hypotenuse and the x-axis. What is it? 12/13. So what would be the cosecant of theta? 13/12. They're reciprocals. We already did the cosine and secant. What is the tangent of theta? It would be 12/5. What would be the cotangent of theta? 5/12. Now, is this a unit circle? No. This is a right triangle, so all of our trig functions can be done on the right triangle. But it's not necessarily a 30, 60, 90, or a 45, 45, 90. That's when we're using the unit circle. Okay, so this was just, we know that this is a right triangle because of the Pythagorean theorem. So now on this one, if I want you to find the cosecant of 60 degrees, okay, once again, here in our unit circle, and some of you don't draw the circle, I just do, this would be 60 degrees. This would come down to the x-axis. Okay, it's in the first quadrant. My reference angle is 60 degrees. Where's my short leg, on the x or the y?
X.
The x, because it's opposite 30. So this would be 1/2. This is radical 3/2. So cosecant. Cosecant, it's a reciprocal function of which one? Sine. Remember, it's the one that's kind of goofy. That the sine goes with cosecant, cosine goes with secant. We wish it was the other way, but it's not. So the sine of 60 degrees is radical 3/2. So the cosecant of 60 degrees is 2 over radical 3. Can I leave my answer with a radical? No, you cannot have a radical in the denominator. So I rationalize it by multiplying by radical 3 over radical 3. I get 2 radical 3/3. There's my answer. So find the primary and then just take the reciprocal of it. Okay, let's look at this one. Cosecant of 30 degrees. Okay, so 30 degrees, where that lands in your first quadrant. Where's my short leg, on the x or the y? The y, and that would be 1/2, 1/2 up here. This would be radical 3/2. The cosecant is the reciprocal function of which one? Sine. And the sine of 30 degrees is 1/2. So the cosecant is 2. Okay, so here we go with this one. Secant of 60 degrees. I don't really have to draw it again. It's just like the one up above. I have 60 here. So this would be 1/2. This is radical 3/2. Secant is the reciprocal of what?
Cosine.
Cosine. And cosine of 60 degrees is 1/2. So secant of 60 degrees is 2. Okay, cotangent of 45 degrees. Everything's in the first quadrant right now. What's sweet about the 45, 45, 90 is we know that both legs are equal. So this is we don't have a short leg and a long leg. The cotangent is a reciprocal of which one? The tangent. And so the tangent is y over x. And so that would be 1. So the cotangent would also be 1. Okay. Now we finally go into something else. 210 degrees. Where's that going to land? Which quadrant? Third. We're big on the third today. What is the measure of the reference angle? 30. It goes up to the x, up to the x. Which is my short leg, the x or the y? The y. Are any negative? Both of them. What's my reciprocal, or what's the primary function? Cosecant goes with sine, and the sine of 210 degrees is negative 1/2. So the cosecant of 210 degrees is negative 2. Okay. On here, evaluate this by checking on your calculator's radian mode. Okay. First, let's just do it, and then we're going to check it on these two. I want to do it on. Okay, on here, cotangent. First of all, which quadrant will this land in? First, and what is the reference angle? 60, because 180 divided by 3 is 60. So my short leg is the x. This is the long leg. So on here, for tangent, it's y over x. But the other one, could you record those over there? Is, if it's y over x, this will be x over y. Correct? Everybody follow what I just did? Okay, because I kind of did 2 steps at once. So I have 1/2 divided by radical 3 over 2. So that's the same thing as 1/2 times 2 over radical 3. The 2's cancel, you get 1 over radical 3. Can I leave it like this? No. You have to multiply by radical 3 over radical 3, and you get radical 3 over 3. Okay, down here, I want to also explain something on this one. Where is this going to land? It's on the negative x-axis. What is this? Negative 1, 0. Somebody asked in her class, I think it was 5th or 2nd, and they said, why can't we draw a right triangle like this? Or when it lands up here, why can't you draw it like this? The hypotenuse is always the radius of the circle. So you can't be drawing triangles like that. Your hypotenuse isn't the radius. So your radius is always 1. Your x and your y are the endpoint of the radius with the unit circle. Does that make sense? So maybe that clarifies some of the things. So cotangent is a reciprocal of tangent, so we know it's x over y, right? So we'd have negative 1 over 0. What happens there? Can you divide by 0? No, it's undefined. On your calculator, it would say error. The tangent is 0. This is the cotangent. The tangent of pi would be 0 over negative 1. That would equal 0. And you'll see why on your graphic. Okay. Now, on this one, This is with your calculator. And on your calculator, even on your scientific calculator, there's a mode. And in the mode, if you're talking about this, you have to change the mode to radians, okay? So on here, like if I go to my mode and I go down here right now, it's interesting because your graphing calculator, which you'll be using later on in other math classes, it defaults to the radians. It doesn't default to the degrees. So if you ever are taking the sine of 230 degrees, you have to change your mode to degree on your graphing calculator. Otherwise, you're finding it of 235 radians. Okay, totally something different. So on this one, how would I go about doing this? Because I don't have any secant here. And this second function, that cosine to the -1, that is not the that's not secant function. I'll tell you what that is in a second. So your steps of doing this is you first would put in cosine of -1 and you would press enter. So use your scientific. I would go cosine of -1.
I thought we weren't allowed to use calculators. I thought we weren't allowed to use calculators.
You aren't, but on this part you would be able to. I would have you on this. Okay, and I just want you to be aware. You're going to have some homework on this. Okay. So you would get, right here, you would get 0.5403. Then what you do, you'd go to x to the -1. Some of you on your scientific calculator have 1 over x. That's the same thing. So I go x to the -1. I'm taking the answer to that. And here is your answer. That's the final answer. Oh, so sorry. Okay, so now, if you don't get that, there's another way of doing it. You could, by definition of the secant, you could just go 1 over cosine of -1 because it's the reciprocal. Is that what you did? You have 1, you divide it by the cosine of -1. Make sure you hit the -1 and not the minus button. Oh, because I did answer. Okay, that's not right. Clear that. Okay, so you go 1 divide by. There we go. Cosine of -1. And you would get the same answer. 1.8508. So you could do it either way. You could first of all do, like on this one, 2 ways on here. You could go the sine of -15, enter it, and then do the, so you could go sine of -15, and then take x to the -1. You hit enter, you get negative 1.5378, and then I go x to the -1 and enter. That's your answer. On these, those aren't 30, 60, 90 triangles. Okay, so this would be the only way of using your calculator. Yes?
Getting 2 different numbers with 2 calculators.
Then they probably, one of them is not in the radian mode. You have to put them in the radian mode first. Okay? So you can check your answer here. If I want to do cotangent, I'll do it the other way on this one. I'm going to go 1, here I want to clear that. I'll go 1 divided by the tangent. And I go parentheses, and I'll go pi divide by 3, and a parentheses. And there would be your answer. and that's your decimal answer. These I could do this way because that was a 30, 60, 90. These were not 30, 60, 90. So the only way we have to calculate this is on our calculator. Any questions on that? Okay, good. Okay, so now go back to this page, just the page in front of it, what we did the warm-up on. And let's go here. We aren't going to do 1. Okay, go to 2. This is making you think a lot. If the cosine of theta is negative radical 3 over 2 in quadrant 3, find theta. So try and find what theta is. And you aren't using a calculator. Draw it out. It's going to be in quadrant 3. So put where your terminal side in. Your terminal side's going to be here. Draw your right triangle. Sarah, where am I going to draw this up to? X-axis. Because we're talking about trig. All of it's right triangles with this on the primary functions. That's a 30, 60, 90. We're drawing it straight up so it's perpendicular. Okay? So, negative radical, we know this is 1. Where's that going to fit, Armin? Negative radical 3 over 2. Well, no. The cosine equals this. What's the hypotenuse equal, class? 1. What does the cosine of theta equal? Is it x or y? It's always x, right? Because it's x over 1. It's the adjacent. So this goes here. Okay? So obviously what goes here? What would this length be? Negative 1/2. So what's the measurement of the reference angle? 30. That's the reference angle. So theta is this entire angle to get it into the third quadrant, right? It's not 30 degrees. 30 degrees would end up in the first quadrant. So what would that whole measurement be then? It would be 180 plus 30, which is 210 degrees. There's your answer. Okay, now let's look at this one. If the point 5, negative 2 lies on the terminal side of the angle. 5, negative 2, what quadrant does that put us in, Zen? Fourth. I'm going to go over 5 and down 2. Okay, so this is the terminal side. So I have, this is going to go up, but here's my circle. This is 5, this is negative 2. Okay. Is this a 30, 60, 90? No, it doesn't have any of the relationships of half or multiplying by radical 3, does it? Can I find the height? This isn't necessarily a unit circle. So it's not going to be 30, 60, or 45 for my reference angle. But all I have to do is find the sine and cosine. Okay? So on here, if I want to find the sine and cosine, I'm going to have to find the hypotenuse. The hypotenuse obviously isn't 1 because 5 squared plus negative 2 squared isn't 1 squared, is it? So I'm going to have to find that. You'd have 5 squared plus negative 2 squared equals the radius squared. So the radius squared equals 29, so r is the square root of 29. Okay, do you see the difference of these? This was an amount that we could see the relationship was 30, 60, 90. This you cannot see that. So Ryan, on the sine of theta, what would that be then? If this is radical 29. You don't know? Here's my theta. What does sine mean? What is it the ratio of?
Opposite over adjacent.
Up.
Over hypotenuse.
So what would that be? Negative 2. Good. See, you have it. And can I leave it like that?
Then you have to multiply by radical 29.
Perfect. And you get negative 2 radical 29 over 29, and you're done. Okay. Will, what would cosine be?
Sine over radical 29, and you have to multiply by radical 29. And you get 5 radical 29 over 29.
Very good. Ibrahim, are you writing this all down? Okay, so let's just take it a little further. What would be my tangent of theta? What would that be? Borna, what would that be? Tangent. Tangent is y over x. Opposite over hypotenuse, it's negative 2 over 5. Okay, last one, and this is key. When it says between 0 and 2 pi, what does that really, in degrees, what would that mean? 0 to 360. So we're having all the values here where the sign is negative 1/2. Where is the sign negative? On the left side over here, in the second and third? It's in the third quadrant because the sign is the y. So that's negative 1/2. Is that the only place? And the fourth. When you did that big chart today, didn't you find out that this was negative, negative, this was positive, negative, right? The y was negative in both the second and third. So what is the measurement of this angle, the reference angle, if this is 1/2? It would be 30 here, and it would be 30 here. So this would be, once again, 210. And what would this be all the way around? This would be 330, right? And if you wanted those in pi, if I would multiply this by pi over 180, you would have 7 pi over 6 or 11 pi over 6. Notice what my reference angle would be 30. 12 pi over 6 would put it at 2 pi. If I take away a 30, it would be at 180. Okay, so this kind of puts it in a different dimension. Whenever you see lengths and widths, x and y, like radical 3 over 2 and 1/2, you know you have a 30, 60, 90. Otherwise, it's the Pythagorean theorem to find your hypotenuse. And you still can find your trig ratios because we're dealing with right triangles because of the Pythagorean theorem. Questions on that? Okay, and then just memorize which ones go with which. Okay, and we're done, and we get to go to graphing.